Okay, our next speaker is Torrey Ritter, who's a graduate student from Montana State University.
All right, well, thank you all for having me. I'm at the Department of Animal and Range Sciences at Montana State University. And I call this talk Ecosystem Pioneers because we all know beavers are really good ecosystem engineers. But for every really well-established colony like the one here on the screen, at some point, a single beaver, a pair of beavers, or a small group of beavers had to disperse from somewhere else and kind of start that process in an area that wasn't, necessarily manipulated by beaver or hadn't been manipulated by beaver in a long time. So those are the ecosystem pioneers. They're getting out there and they're getting that process going. And the reason we want to look at these guys is we figured this is kind of our best chance to study the natural ecology of beavers in a scenario that relates really well to beaver-mediated habitat restoration. So with these restoration type scenarios that we've all been talking about, you're kind of doing the same thing. You're trying to get a beaver colony, or you're trying to get some dams going in an area that doesn't have those structures already and doesn't have those habitat manipulations already. So that's why we want to look at this sort of natural dispersal and settlement process. So as of right now, almost every study that's looked at beaver habitat suitability follows the same general study design. They go into areas where beavers have occupied, they measure the habitat conditions there, and they compare those habitat conditions to either unoccupied or abandoned stream segments. And then the variables that come out on top from those studies go into these sort of habitat suitability models and indices. And those are really useful for identifying areas on the landscape that beavers could be or that beavers should be. But it is questionable whether we can use those results for the specific selection of restoration sites and looking for these areas where beavers can start new settlements in novel areas. And that's because beavers are ecosystem engineers. They move into an area, and through this, that engineering capability, they drastically change those habitat conditions. So if we're going to use those results to identify potential restoration sites, we're basically making the assumption, that that selection pattern that we're observing from the unoccupied versus unoccupied design are the same selection patterns for those beavers settling in new areas. So here's a quick example. This is in the South Fork of the Madison up in our study area. You've got a lot of variation in stream width and a lot of ups and downs as far as the stream's depth go, and you've got those little patches of riparian vegetation. So this is in 2013. Some beavers moved in, I believe it was, right at the end of 2013. And by 2015, you've lost a lot of that information that may have told you why the beavers settled there in the first place. Because that damming activity has completely flooded that stream channel. They've removed a lot of that vegetation. And this is an area where there isn't a lot of sediment supply, but especially in areas with a lot of sediment supply, that channel will already be starting to fill in within a year or two. And of course, as these colonies progress and get older, that information just kind of fades away. All those things you could have learned about why they chose that specific spot gets covered up by all of these engineering activities as they expand those colonies. So that led us to the question, how can we understand habitat selection by these beavers when they're starting these new colonies, when they're so quickly and dramatically changing that habitat? And that's where the ecosystem pioneers come in. So when beavers are 1 to 3 years of age, generally, they take off from their natal colony, head out on their own, and they got to try to start a new colony and get a territory somewhere. And especially in areas where there's particularly high densities of beavers, and there's not a lot of good settlement sites available, they're usually forced to settle in these kind of suboptimal and marginal habitats, areas that don't have a lot of beaver manipulations already, these unmodified habitats. And again, that provides the best natural analog we have to these restoration type scenarios. So we came at this research in 2 ways. We radio marked dispersal age beavers and followed them throughout the dispersal process to kind of see how far they're willing to go and what types of settlement sites they're looking for. But we also modeled mapped beaver activity over 2 major river drainages, and that allowed us to identify where are those unmodified, sort of suboptimal habitats, and then we could look for new settlement sites specifically within those types of streams. And then we can compare those new settlement sites to other unsettled sites within those unmodified stream segments and figure out what are those kind of baseline habitat conditions they need to start a new colony. So I wish I could had enough time to talk about both aspects of research, but for this audience and for this symposium, I think I'm just going to focus on this new settlement site selection. But overall, what we want to do is just be able to use the ecology of beavers to better inform the selection of potential restoration sites. This is our study area in the upper Madison River drainage on the left and upper Gallatin River drainage on the right. If you were to drive up, well, you can't really see that road, but if you were to drive up this road here, ooh, I stepped away from the podium. Basically, if you were to take this map, put it on top of the other one, they're very close, they're pretty well connected, but they're very different drainages. There's twice as many colonies per kilometer in the Madison drainage, and that's really a reflection of differing habitats. In the Madison, you have these much slower, low gradient, really large streams with wide riparian areas, and these beavers establish these big, giant colonies. Whereas in the Gallatin, you have much higher energy streams, higher gradient, a lot more dynamic colonies, and more in size streams. So that's why we see that variation in the colonies per kilometer. So we have a really wide range of habitat conditions, and hopefully that allows us to get to some of those kind of core habitat principles that make up these new settlement sites. So this is the result of our field work. We get these beaver activity maps. We basically just walked along all these stream drainages and marked all active and inactive beaver sign. And we did this over 3 different years. So in yellow, you have your active colonies. In red, you have what we call abandoned colonies. So those are colonies where they still have dams and lodges pretty well in place. And if a beaver was to move into an abandoned colony, it'd basically just have to make some repairs, and it'd have a good, fully formed colony ready to go. And we differentiated that from relic colonies, which are in black. And those are areas where they clearly had a colony at some point, but now it's just really old, blown out lodges and dams. And then there's also unoccupied stream sections, which have little to no beaver activity. If they were ever there, the stream has moved around enough that it's kind of erased that sign. And then there were a few sections that were so completely unsuitable for beavers, we decided not to include them in this project. So to be clear, we're looking for new settlement sites only in unoccupied and relic stream segments, because we don't really know if they move into abandoned colony, we don't know the trade-off between habitat conditions and the presence of those old structures for them to use. So we're considering it a new settlement site if it was previously considered relic or unoccupied. So we'll zoom in on one of the new settlement sites we had. Again, these yellow doesn't necessarily mean it was a new settlement site. Some of these yellow are just big old active colonies, but this one down here was a new settlement site. Just to show you kind of how we collected the habitat data, we split all of the stream segments into 400-meter, what I'll call sampling segments for the rest of this talk. And this is our experimental unit. So we measured habitat conditions over each one of these sampling segments. And we picked these variables pretty much directly out of the habitat suitability literature that's been published over the past 50, 60 years. But also included a few other things we thought may be a little more important to this new settlement site selection, and also took advantage of some local data sets, the Montana Natural Heritage Program, Wetland and Riparian Framework, to add some additional variables that are specific to our area. So this is what I'll call GIS-based habitat sampling. This is sitting at a computer using GIS and aerial imagery to collect these habitat variables. But we also want to look at more fine-scale habitat conditions. So for each one of these new settlement sites, we generated random points throughout the entire length of that settlement site and compared it to a paired stream section that was the same size within the same stream. And for each one of these points, we were actually out in the field, getting wet, measuring stream depth, stream width, and these more fine-scale habitat characteristics that you can't get from remote sensing data and aerial imagery. So that leads us to 2 basic analyses. Oh, and I'm sorry, I'm going to call that field-based habitat sampling. So this leads us to 2 general analyses. We used mixed effects logistic regression to look at those GIS-based habitat components, and again, limiting it only to those relic and unoccupied stream segments. And so this analysis allows us to look at what are those habitat variables that kind of distinguish these new settlement sites when you're only looking at the unmodified kind of suboptimal habitat. So that will give us some really cool information, but we also wanted to compare that type of analysis to the more classic approach of using all of the stream segments in the study area, classifying them as active or inactive, or occupied and unoccupied is what I called it earlier. And then, but basically compare those 2 types of analyses and see if we were right, if using that classic approach to studying beaver habitat suitability gives you a different picture of habitat selection than the new settlement sites in relatively unmodified habitat. And then for the field-based stuff, since that's more of a paired comparison, we have a settled site and an unsettled site that's somewhat related to it. We just use a signed rank test, a non-parametric test, just to basically see if there are any dramatic differences between settled and unsettled stream or settled sites in those fine-scale habitat variables. So to get into the results, we found 11 of these brand new settlement sites in the Madison drainage and 16 in the Gallatin drainage. And you'll notice they're pretty clustered in their distribution, and that's more of a reflection of the stream type, I think. So in these areas where you see those clusters, those are a lot higher energy streams. So in those areas, an active or an abandoned segment is going to be converted to a relic or an unoccupied segment much quicker because those higher energy streams are blowing out the dams and sort of erasing those colonies in a way over time. So we did see a pretty big difference between those two drainages in terms of beaver activity. The Gallatin drainage had a lot more unoccupied and relic segments. And that's, again, is what I just talked about, that those higher energy streams are converting those segments to a different state a lot quicker. So we had 27 total new settlement events, but of course a new settlement event can take over more than one sampling segment. So overall we had 48 total sampling segments that were part of new colonizations. And we had 613 sampling segments total. It's about 245 kilometers of stream. And of those 613, 373 were considered relic or unoccupied. So these are the ones that are available for a new settlement to pop up in. And as you can see, we had almost twice as many of those new settlement segments were previously relics. So already there's some evidence that even without dams and lodges in place, they're already selecting for somewhat pre-engineered habitats. So for that GIS-based analysis, our top model had these 4 variables in it. Stream gradient over the 400-meter segment had a negative influence on settlement site selection. And that's pretty much every beaver study ever done has found that beavers like low gradients. So it's not too surprising that that came up. But it is kind of cool that it's measured at a 400-meter segment scale. So even at that small of a scale, they're still looking for those areas with a little bit lower gradient. Woody riparian vegetation cover had a positive influence, not too surprising. They need a patch of woody riparian vegetation. And then we grouped the wetland types from that Montana Natural Heritage Program database into these habitat types that represented general groups of wetland types in our study area. So the low wetland type that had a positive influence on settlement site selection, that was just low-lying areas directly adjacent to the stream channel. Usually they were sedge meadows or old stream channels and gravel bars, areas that would be relatively easily flooded if you were just build a small dam. And the proportion of water body wetland type, which had a negative influence on settlement site selection, that can really be interpreted as the proportion of each stream segment that was made up of stream channel. So they're basically selected for areas with smaller stream channels overall. And I say they're selecting for these areas, but as you can see, we have pretty wide confidence interval. We have a lot of uncertainty around those estimates. Part of the reason for that, I'm sure, is because, as I talked about earlier, we have a really wide range of habitats. So beavers are dealing with a lot of different conditions in our area, depending on what stream they're in. So we tried to account for that a little bit. In our models, we used a random intercept effect of stream ID. So basically, this just takes the slope coefficients from those top variables, applies them individually to each stream in the study area, and you can see there's pretty wide variation just in the baseline probability that a stream is going to be settled by beavers. So that may be part of the reason that we're seeing the uncertainty of those estimates is that there's a unequal proportion of streams that are contributing more to that model. So how does that compare to that classic approach of looking at active versus inactive? This is another sort of random effect plot. Basically, if those bars don't overlap 0, that effect was considered significant in the model. We had a lot larger sample size for that analysis, so we were able to include a lot more variables. We did see 2 variables that were the same in both types of analyses. But the really interesting thing here, I think, is of all those variables, there's really only one, presence of secondary channel. The rest of those variables are something that beavers can manipulate and often really do manipulate quite heavily, especially if they've been in the area for a long time. So we really don't know, did the beavers select those areas because they have all of these resources, or are those resources the way they are because beavers have been there for so long? And that's kind of that confusing aspect of the classic approach to beaver habitat suitability research that I was talking about. So we did see some variation between the two analyses. Finally, for the field-based stuff, really the only difference we saw between settled and unsettled sites had to do with stream depth. Settled sites overall had deeper stream depths. That's not too surprising. That's pretty consistent with most beaver studies. What I think is really interesting here is that not only in cross-section, we measured depth at each one of our sampling points at four spots along the stream channel, and then we used the standard deviation of those depth measurements to look at as a variable to look for differences between settled and unsettled sites. So not only the variation in cross-section was higher in settled sites, but also when you take the average of those four depth measurements and then look for the variation longitudinally along the stream channel among all of those sampling points, that also was a lot more variable at settlement sites. So they're looking for a lot of variation in water depth. So what did we learn about the ideal new settlement site for beavers looking to start a colony in relatively unmodified habitat? Well, they definitely seem to need some hiding cover, and that may have to do with that stream depth, having variation in stream depth. A lot of these new colonies sort of followed this same, they were very similar sites. It was a deep pool where they had some sort of undercut bank where they had their initial lodge or dam, or initial lodge or bank den. And then as that pool got a little shallow near the shelf, that's where they put that first dam. So by doing that, they don't have to build that big of a dam to get that water in that pool deep enough for cover. But a lot of these variables really seem to be related to dam efficiency and dam stability. So having a low gradient stream segment just means the water's probably not going to have as much power to blow out that dam. But also having those low wetland types right along the stream channel means that they are not only flooding areas next to the stream easier, but when spring floods come through or when some sort of high water event comes through, it spreads the influence of that water out a little more, and it's not all just pushing against their brand new dam they worked so hard on. And then just having some access to forage, not too surprising, they just like these dense patches of riparian vegetation. And that was really obvious in the field. We'd walk along these streams and all of a sudden there'd be this nice dense patch, and usually beavers were looking for those little spots. So we also learned some more things in the context of beaver-mediated habitat restoration from looking at these new settlement sites. They really seem to like pre-engineered habitats, which is not too surprising considering a lot of the talks we've had today, where if you give them a boost with some beaver dam analogs, they seem to really like that. We had a lot more selection for those relic stream segments, so even if it was a really crappy old lodge, they would still use that as they were establishing those new colonies. But we also saw a really high rate of abandoned segments being reoccupied as well. So there's really, those pre-engineered habitats pretty much act as magnets for these dispersing beavers on the landscape. We also saw that these settlements were really dynamic, so 54% of the new settlement sites we were able to track for at least one more year were abandoned the next year. And oftentimes those beavers had just moved up or downstream a little bit. So to really plan with getting beavers started in a new area that they're going to have to move around to take advantage of shifting resource availability and to have to deal with possible dam blowouts as they're trying to find just the right spot to get going. And finally, habitat suitability was very stream specific. There's going to be different limiting factors for each stream that are going to encourage or prevent beavers from being successful there. And finally, we did see evidence that following that general pattern of looking at unoccupied versus unoccupied habitats did kind of skew our perception of new settlement site selection and sort of promoted habitat variables that may be manipulated by beaver activity. So with that, there's a lot of people I would love to thank individually, but I mean, there's an unbelievable number of people that volunteered their time and money to help make this project possible. And if you have any questions about the beaver dispersal aspect of our study, if you want to learn about all these guys we messed with, please email me or please come find me at the conference and I can tell you more about that. And I think we have time for some questions. Yeah, that's it. Yes. Yeah, so that was an aspect of the other part of our study. So we found that mostly they were really good at surviving in our study area, but the only mortalities we had from predation were 3 beavers that had just settled in a new territory and were kind of getting established, and those were all mountain lion predation. Other than that, we had almost no mortalities, although we did have some that just kind of disappeared and we never figured out what happened to them. We also had a tularemia outbreak in our study area, so that was our biggest source of mortality was that disease. But those generally weren't dispersing beavers, they were just ones that hadn't left the natal colony yet. Thank you.